So it begins. So pictured on
I'm just going to mute myself here. Hang on.
Pictured on the screen is the front of the Roman Pantheon. And this building is 2,000 years old. And it's just disgusting that we as a society can't come anywhere near to that. The 9/11 memorial that the Pentagon had designed, they requested that it last 100 years. And we need to change this philosophy. Today we're going to learn about VOC rules, reasons, impact, but most of all we're going to learn how to make the world a better place to live through the medium of concrete. Concrete's place in the world is really everywhere. It's the second most consumed item in the world behind only water as measured by weight. Concrete comes from the Latin word concretus, brought together, and it consists of a binder and aggregates. In this case we're looking at Portland cement and stone, but it could be Elmer's glue and diamonds. That would also be a type of concrete. Not sure what you do with it, but there you go. Nature formed cement 12 million years ago. And in 1824, Joseph Aspin patented Portland cement as we know it today. 19 billion tons of concrete were produced in 2010, a little behind on my numbers. Quadrupled since 1970, will easily double by 2030. The best, most accurate guess we can arrive at is that 8% of the man-made CO2 is created through the process of cement production. This is how they produce Portland cement. The materials are taken out of the ground somewhere, these materials, sent to a cement factory. They get superheated, we're talking 2,700 degrees Fahrenheit, and they go into a molten state. These materials mix together that we call clinker. It's then ground up inside of giant machines, and out of the far end of it comes what we know as Portland cement. In this process, they use 6 million BTUs per ton of Portland cement to make this happen. So to give you a frame of reference, when you see a full concrete truck driving down the road, it has 18 million BTUs worth of Portland cement in the back end of it. Concrete is comprised of Portland cement, water, stone, sand, and admixtures. Not an inch of concrete gets poured in the civilized world without some sort of an admixture in it. If you were to take Portland cement out of these ingredients, what you would have is a pile of wet rocks and sand. So that's where we need to look carefully, because that's where the magic happens. 75% of Portland cement is comprised of tri- and dicalcium silicate. And when these silicates react with water, they form calcium silicate hydrate and calcium hydroxide. This is what provides the early and long-term strength to concrete. The additional materials form the completed matrix of the concrete, and that's what you have. What we're here primarily to discuss today is free water. When they make a cubic yard of concrete, they start out with, give or take, 32 gallons of water. That chemical reaction that we just looked at, Portland cement and water, uses less than half that water, leaving you with approximately 17 gallons of free water, or water of convenience, in the concrete. I customize these presentations to each architectural firm that I go to, and this was one of their projects where I most recently gave this. It's a 184,000 square foot hotel, and inside there would have been 38,000 gallons of free water in the concrete slabs, waiting to come out into the occupied space. A cubic yard of concrete at 4 inches thick covers 81 square feet. So every 8 by 10 area you see at one point in time contained an extra 17 gallons of water. Imagine if I was to dump 3 5-gallon buckets of water into maybe your walk-in closet. You'd be up to your ankles in water. Well, that's what's in the slab. And if it was 6 inches thick, it would be nearly 60,000 gallons of water in there. Concrete drying times, the ability to get rid of this free water or extra water, are considered to be 40 days per inch of thickness by all industry experts, including myself, under ideal conditions. And these ideal conditions consist of an enclosed conditioned space. So build your building, turn on your HVAC, and that's when the exchange of moisture truly begins in earnest with traditional concrete. Inside that concrete slab, it's 100% relative humidity. And when you condition the space, it now becomes 50%. That exchange is going to occur from the high to the low. And this happens frequently 10 minutes before the flooring installer gets there or the roofer arrives on site. And this has become a problem because in 1999, the EPA, in an effort to protect us and future generations, lowered the allowable VOC limits inside the building envelope through the Architectural and Industrial Maintenance Coatings Act. And where that had a huge impact was on flooring adhesives. While they could certainly have the moisture pass through the flooring adhesive, it's going to hit the impermeable membrane of the flooring sitting on top of it and blow it off. And now more and more manufacturers in every phase of construction are beginning to make products that contain no VOCs. And so it's extending to roofing, fluid applied air barriers, etc. And until we came along, the only legitimate solution was a topical treatment on top of the concrete to slow the moisture's passage through to the material. And it travels through the concrete through the bleed channels. When concrete is first placed, the heavier materials settle to the bottom, water is pushed out, and bleed channels are formed. These bleed channels provide a perfect path for moisture vapor emission to leave the concrete, come up here, get underneath this impermeable moisture membrane of a floor, and re-emulsify this now water-based adhesive. So if you could get rid of that water or the highway on which it travels, you could stop this problem. You could also go a long way towards solving this issue. If you could make the concrete you put in place outside impermeable, no bleed channels, you're obviously going to extend its life cycle. We're not going to exclusively talk about flooring issues today, but it's certainly where this problem got its start. Well, we've been fortunate to bring a solution. In that, in most industries, the standard cure for this is a topically applied material. First, they test with these items we see here, and if they pass the test, they would install the floor or roof or whatever it is. However, in the case of approximately 60% of the commercial projects, an extra step is necessary. An architectural firm in Boston told me that 100% of their projects failed these two tests, so they simply built this into their process. And what this process is, it's designed to deal with all that extra water in the concrete. So they take one of these machines and they run it around the floor as a shot blaster, shoots lead BBs into the floor, rips off the top matrix so that this material can be applied. This is an epoxy moisture remediation material that slows down the rate at which moisture leaves the concrete slabs. Doesn't stop, but it slows it down. So now they've shot blasted it, put this epoxy on, you can install your floor. No, you can't, because flooring adhesive won't stick to that epoxy. So you need to self-level, and then you can install your floor. So that's the process, and as you can imagine, you're $5 to $8 a square foot, depending on where you are in the marketplace. Not to mention the fact that when you begin putting this epoxy and self-leveling down, no other trade can be in this space. It's shut down from any other activity. It's a project killer. And this is how moisture travels through the concrete, through the capillaries, bleed channels. The free water in the slab comes out in the form of vapor emission. One thing that's been suggested is to reduce the amount of water in the concrete. However, in the back end of this concrete truck, inside the drum, there are 33,000 pounds of Portland cement, stone, sand. And in order to mix that up into a homogeneous, usable mix, then it gets dumped into the concrete pump truck and it gets pumped up and over into the job site. Put in place, water acts as a finishing aid, offers it some self-leveling characteristics. And now what they've done here is they've created an interior concrete slab that's ready to perform its two primary functions in the building space. It's there to be a structural element of the building, and appropriately incalculable amounts of engineering time have been spent to make sure that is so. Its other primary function is that it's there to receive floor covering, because that's the next step in its life. And today we're going to give you a tool so you can engineer that slab to receive floor covering on your schedule. This particular type of flooring material is one of the most difficult. It's frequently used in medical applications. It's a rolled material, usually 6 foot 6 inches wide, and where the seams occur, they heat weld it. They run essentially a glue gun down there. So there's nowhere for the moisture underneath to escape, and it blows the floor off because it's a water-based adhesive. So here's the solution we propose. Remember our tri- and dicalcium silicate, form calcium silicate hydrate, calcium hydroxide. Well, our water vapor reducing admixture reacts with the calcium hydroxide and the free water to form additional calcium silicate hydrate gel, where the capillaries of the concrete would be in traditional concrete. This is what it looks like. Water vapor reducing admixture reacts with the calcium hydroxide plus the free water and makes this slab impermeable. If this were your basement or your garage concrete floor, you could now take a cardboard box filled with your most precious mementos and set it on that floor, and it's not going to get damp and moldy. Making more of this, filling in more of these holes. On all of our warranted projects, we send out cylinders taken from the concrete truck at the time of placement to an independent lab where they conduct this test, and we send them a 4-inch diameter by 8-inch cylinder, and they slice a 2-inch hockey puck out of the center of it, and they push water through it. And in this particular test, these were the results: 5.17 times 10 to the minus 11th centimeters per second. And if you do the math on that, it means it would take 6,318 years for moisture to pass through a 4-inch thick slab. And this test was conducted with a differential head pressure of 15 pounds applied hydraulically. Hydraulic pressure underneath the slab is typically only about 1 pound. So in summation, for flooring, roofing, and a variety of products, here's the problem. The free water in the concrete, the fact that traditional concrete is porous, allows for the free passage of moisture. The covering is impermeable, and the adhesives are now water-based. And when you get big differential air pressure and humidity changes is really when this problem is at its height. And you can solve this problem by using a water vapor reducing admixture that provides a warranted solution. When you're looking to select a proper water vapor reducing admixture, you want to make sure that food-graded reactive materials are being used for consistency. And make double sure that the manufacturer that you're using has a solid factory quality control program in place. And possibly most importantly, that there's an active field QA and QC program in place. And of course, it's imperative that they have ASTM C494 Type S approval for admixture as well to hold any of the stakeholders harmless in the event of some sort of a calamity. There should be factory-trained ready mix providers and finishers, and you should provide a full warranty to the project, material and labor, to replace any material that's failed due to moisture vapor emission. So in the real world, you can see this is water here, but this is vapor. Vapor comes right up. It takes a good push to get the water through, but vapor floats up. So if you could eliminate these highways and the water that's creating the vapor, you could stop this problem. You could also make a dent inside of buildings in this problem. This is black mold. Where there is no moisture, there is no mold. The Institute of Medicine, which is a user of water vapor reducing admixtures, talks about environmental factors that influence respiratory disease, and that's building dampness. So if you could take your 70,000 gallons of extra water out of that building, make it into more of what makes concrete strong, you're going to provide a healthier interior environmental quality. A brief history of admixtures. In 300 BC, the Romans used a variety of things, blood, milk, animal fat, to make concrete less permeable and to increase its longevity. And to this day, there is some derivation of animal fat being used in concrete. And in 1975, the water vapor reducing admixture, as we know it today, was brought into the marketplace to be a waterproofer and a workability aid. The secret to the performance of water vapor reducing admixtures and to the outstanding benefits it provides is that it internally wet cures the concrete. It converts that extra water into calcium silicate hydrate gel, which has a moisture content and acts as a wet cure. So all the problems that are eliminated when you wet cure concrete are eliminated by internally wet curing it as well. And you truly have a superior concrete slab. We have people using this material who are just looking to improve the quality and workability of the concrete. They're not putting any flooring or anything on top of it. We've done projects all over the world, and really only in one case have we ever had any sort of plastic shrinkage cracking reported to us. That was in the Mojave Desert. It was 100, it was sunny, and it was windy. They, however, were still able to use the slab, no problem. With the other millions and millions of square feet that we have in, not a single plastic crack, because that's all about curing. When you have water vapor reducing admixture in your concrete that won't allow the passage of water vapor, it certainly won't allow the passage of methane and radon. This is a chart showing the size of these various molecules. Water vapor can't get through, radon can't get through. I last gave this in New York, so I have their map there, but radon's a huge problem everywhere, as we know. And one of the things that they recommend, this is from Purdue University, is to use a more dense concrete mixture for the foundation and the floor. So that's what we're providing. There are any number of materials that can be post-applied to concrete to make it water and damp proof, but not one of them is as efficacious as the water vapor reducing admixture, and every one of them is more expensive. If you're doing tilt wall, you can stand that wall up faster. You wouldn't need any additional air or waterproofing membranes. And one of the things we haven't talked about yet is color. When you see a concrete slab, it frequently has a white mottled effect to it. But when you see a slab that has water vapor reducing admixture in it, it looks much more monolithic, all one color, almost as if it's painted. And the reason for that is the traditional concrete allows moisture vapor to flow through it and carry bits of portlandite and salt deposits to the top of the concrete. Water vapor reduced admixture will not allow that. That's one of the ways you can tell that we're in there, just by the appearance of it. Here's some, this firm, I did this presentation at the 9/11 Memorial in New York City. That's what we're looking at here, the reflecting pond. These are some of their projects. You think about the benefits to exterior concrete, they're tremendous. The American Concrete Institute talks about concrete durability being a function of impermeability. And I think inherently we all understand that. You talk about waterproofing, keeping things out of the concrete. This is water vapor reducing admixture. This is a crystalline growth formula. It took 250 years for moisture to pass through this test sample, and it took 7.2 months there and 3.6 months against the control. So they certainly are doubling the waterproofing capacity, but nowhere near impermeability. Talk about rebar for a minute. You know, rebar rusting is really a product of overcarbonation of concrete. Inside the concrete matrix, the pH is about 11.5 to 12, and rebar can't oxidize there even if water gets to it. However, as concrete carbonates from the top down, it will lower the pH and allow for the rusting of the steel inside there. So by disallowing formation of bleed channels, you virtually stop overcarbonation of concrete. Freeze thaw and UV are major issues in this area, and we stop the negative impacts of that. All these things are a byproduct of a capillary system, free water. Had this concrete been placed properly, they wouldn't be replacing it here. On the lower right, we have an interesting little thing. They used a water vapor reducing admixture in this mortar, but not in this mortar. See the efflorescence forming? No efflorescence. No capillaries, no efflorescence. Here's a few waterproofing applications. And regarding the what goes on with the EPA and making more things waterproof, eventually they'll get around to it. But in the meantime, manufacturers are constantly being forced to put out information about the VOC content of their products. And less is it acceptable to have VOCs in there. So we're all eliminating VOCs in the process, and we're running into this practically every day now with roofing manufacturers asking to use our system to solve their problem. The improvements to concrete by controlling the free water and the bleed channels are endless. All the problems with concrete are a byproduct of bleed channels, uneven expansion, free water leaving at different rates in different part of the concrete. Here's an assisted living facility. This is actually in California. When this firm has been using water vapor reducing admixtures to stop their flooring problem, but through observation of the concrete at the job site, they recognized the superior quality they were receiving, and they now use it in every inch of concrete that they put in place. The benefits of a water vapor reducing admixture are absolutely endless. Endless. By wet curing that concrete, you're just dramatically improving its performance. We're going to shift gears now and talk a little bit about infrastructure. Here in the U.S., we received a D. The executive director of the American Society of Civil Engineers makes the following statement: the problem is that there's been a mentality of patch and pray. Well, I would say two things to Mr. Natal, that A, if you put concrete in place that's impermeable, you're not going to be in the same position. You're going to dramatically extend its longevity, A. And B, if you do need to repair concrete, make sure you repair it with a material that's impermeable. Cementitious patches, Portland cement-based materials, aren't dramatically different from what they're fixing. They allow the free passage of moisture, which is the reason you needed to repair it in the first place. We recommend an ionic bonded material, a two-component system that is impermeable. No primers are required. The prep is a little less limited in that you don't need to dig under the rebar for it to grab, because it'll grab nicely onto the face of the rebar. Of course, we want you to be down to dry, sound concrete. And this product can be used with no critical mix ratio, so you can use the horizontal, vertical, and overhead and not lose any strength through more or less liquid being added. This is an ionic bond over here. It bonds directly to the substrate, and the weakest point of the repair at that point is the substrate. If this was our repair material and you were to knock this off sideways with a hammer, it would absolutely take some of the concrete with it because that bond is so strong. Acrylic modified Portland cement-based materials sit on top of a primer or a bonding agent. They don't bond chemically and physically the same way that we do, and that's why the failure rate is so dramatic over here. That's why it's called a patch. A patch is what you do until you do it right. When you use an ionic bonded repair material, the real key to the thing is the bond. It just bonds, bam, it's not going anywhere. Zero shrink. It will follow the concrete as it grows and shrinks. We have the testing to prove that. And we set out to make a permanent repair material, and we accomplished that goal, but it also happens to be fast setting. You can walk on it 20 minutes, you can drive on it in 1 to 2 hours. We do lots and lots of DOT work throughout the world, and you can use this material down to 14 degrees Fahrenheit, and I believe that's minus 10 Celsius, and it's impermeable. So if you're looking to do some repairs, you should use a permanent, long-lasting repair material that is impermeable with a tenacious bond, fast return to service. And even on the front end, projects tend to be less expensive because there's great labor savings to be had here. And certainly over the life cycle, the cost is lower as well. This is a project we did in Saskatoon. Lots and lots of chemical salt-free thaw occurring here. And as I understand it, there was a cement-based patch on either side of us that did not stand the test of time. These are some repairs we've done using this ionic bonded material. Gas stations, huge problem in the world, of course, with gas going into the porous material. You go through, do the deep fills. Overcoat it. They were able to do this while the gas station was still open, and once the prep work was complete, they were reopening it for business in 3 to 4 hours. You can slope it. So, in summation, protect your concrete with a water vapor reducing admixture, solve your adhesion issues, and if you do need to repair concrete, repair it with an impermeable material. This concludes the generic portion of our program. The most important thing that we bring to you, the Specialty Products Group and IMCO Technologies, is quality. We take the highest order of raw ingredients and work from there. Absolutely any time you pick up a bucket or bag of ours, we are best in class. Every time. We've been talking about vapor lock concrete admixtures as a water vapor reducing admixture. We're absolutely the best tested product on the market. Something that's unique to us in this segment and really within the entire concrete industry is the fact that we have markers inside there. So through a targeted spectrographic analysis, we could take a core from this project here, 10 years later, and identify the fact that we were or were not in that concrete. And we provide a full labor and material warranty in the event of a moisture-related failure. That's VaporLock 2020. VaporLock 2021 for waterproofing, waterproofs concrete and densifies it to an unprecedented degree. We have NSF approval to use that in potable water applications. We make a variety of topical products that can be applied. They use the same chemistry. They penetrate into the capillaries, react with the calcium hydroxide, form CSH gel, and fill up the capillaries of the concrete to water and vaporproof it topically. On the upper left is kind of an interesting project. That's FW Webb here in New England. They're building 63 large-scale plumbing supply warehouses with a front-end showroom, and they used VaporLock in all their concrete. They didn't have to put a material on top there to stop dusting in their warehouse because there is no dusting when you use VaporLock. They polished the showroom floor. They went much faster because VaporLock had already done much of the densification that's necessary in the polishing process. The Specialty Products Group is pleased to be offered MGcrete, which is the ionic bonding material we discussed earlier. Zero shrink, bonds tenaciously, and in 45 minutes it's 2,600 psi, 11,000 at 28 days. So you can see you can use this in horizontal applications, vertical I guess, horizontal, overhead. It's amazing. We make a cool roof product, which is a two-component roll-on system that contains a photovoltaic titanium dioxide that acts to clean the environment and as a self-cleaning agent for the roof. We make an adhesive and coating stripper that contains no VOCs. We clone first-generation microbes to consume hydrocarbons. We have a mold assassin, no VOCs, no bromides. So, we'd like you to work with us to preserve the future. That's your cue. Go.
Apparently we're all